Hello and welcome to your notes for today. These are going to be super simple and super easy because we've been talking about functions all week at this point. So hopefully this is nothing new and this actually makes a ton of sense for you guys. So I'm not going to completely fill these notes out because I do want you guys to do a little bit of it, but what we're doing today is we're going to be looking at functions on a graph. Either they've given us the input and the output, which we need to graph, or they've given us the graph and an input, and we have to find the output based on the graph. So before, the rules that we were given were an algebraic rule, but this time they're either giving us the input and the output, or they're giving us the physical graph that we can see. So let's look at this top part. Again, these are your notes for today, so these are going to get glued in. I haven't glued mine in yet, obviously, but these will go into the next page of your notebook. So let's look at what they've given us. So they said graph f of 2, which equals 4, which means this input value, which is an x, is equal to a y value, right? So when the input is 2, the whole thing, the whole f of x function, or y, will be equal to 4. So when we write that as an ordered pair, it's 2, 4. And so over here on this graph, we're going to plot 2, 4, which would be over 2, up 4. The next one would be negative 3 and 1, right? So for the function, when you plug negative 3 in as the x value, the output, or the y value, will be 1. So if you write that as an ordered pair, it would be negative 3, 1. So what they're doing is they've already, over here, they've essentially told us what the input is and what the output is. So we don't even need the rule. The rule helps us find whatever's missing, but they've given us both parts. So we don't have to do anything except for write them together and plot them, because we know that function rules are an algebraic way to look at a graph. So you can have a rule that for every input you get one output, and those actually correspond to a point on a graph, which you can then combine and you can see. So we don't need the rule because they've already given us both input and output. All we have to do is show what it ends up looking like. So to plot negative 3, 1, I will go right there. And then the next one and the next one, you guys are going to do on your own. And you're not going to need to connect these dots. Okay, so these are just dots on a graph. There's no line that's going through them, kind of like the example we had where there were dots all over the graph and we had to do the vertical line test and see if it was a function. Some of them have lines, some of them do not. So you guys will do these two based on the numbers given, and you will plot them as well, and I'll check for that. And now let's scoot down to the bottom half of this graph. This paper, and look at this graph. So the graph of f is given on the right. So again, remember that f letter in the front, it just lets us know what the name of our function is. And so I know that this is f of x. This is the f of x function line shown on the graph. And so I don't need to know what the rule is to plug this in and find my y, because I can look right here and find the x value of 0, and I can figure out what the y value would be based on this picture. That's the beauty of a graph. So I know that a lot of us freak out when we see graphs, but whenever you have a graph, it actually makes your work a lot easier because you don't have to do any math. You can just look and interpret and analyze what you're looking at. So it says find f of 0. So again, any number in parentheses, that is your x value. So you need to find an x of 0. Where on this line do you see an x value that is 0? And if these numbers are hard to read, I'm going to go over them real quick. It's 0, 5, 1, 2, 2, 1, 3, 2, 4, 5, and 5, 10. So those are my numbers. Where on this line do you see an x value of 0? Me personally, I see it right here. This point has an x value of 0. So when the x is 0, what is the y at this point on this function? It's 5. So for this function, looking at this function, when my x is 0, my y is 5. f of 0 equals 5, meaning when you plug in 0 on this function line, you're going to get 5 as the output. Now, what if you plug in 1 as your input? It's not going to be 5. We've already used that point. So where on this function line do you see 1 as your x value or your input? It's right here, 1, 2. When your x is 1, what is the y at that point? It's 2. So you're going to do these two the same way. Now, E and F are the opposite, right? So they're asking you to find x, which means you do not know what x is. But they do tell you that f of x equals 10. And what do we know that the entire f of x is equal to? F of x is just another way to write y. That's just another way to write y. So both of these just basically mean y equals 10 and y equals 2. So what you have to do is find a y value that equals these numbers and figure out what the x value is at that point. So let's look at E together. Find x such that f of x equals 10 or y equals 10. Where on this f of x function line do you see a y value of 10? Here. When your y value is 10, what is the x value? It's 5. So when f of x equals 10, then the x equals 5. And you're going to do the same thing for f. When y equals 2, what does the x equal? Okay, because every single one of these ordered pairs has an x and a y, and they go together. When the input is a certain number, the output is a certain number, and it works for every single point on this graph. When you plug in 0, you will get 5. When you plug in 1, you will get 2. If the output is 10, the input has to be 5. These points have to be the only thing that work. So do these 3 on your own, as well as these 2 on your own, and make sure when you upload your notes for today, those are both completed.